What is up, people? What is up? We have finally finished chapter. We have finished chapter 3. Now, this is 3.1, but in the other book, we have finished 3.2, 3.3. And we have already finished chapter 3. So, if you want a quick recap of what we have done so far from chapter 1, chapter 2, and chapter 3, I will be uploading every lecture one by one from chapter 1, chapter 2, and chapter 3. Today we start off with chapter 4. So with the higher order differential equations. So rather than having, which means we're going to, so previously in chapter 1, 2, and 3, we have encountered the initial value problem, initial value problem, homogeneous and non-homogeneous, and all the other stuff using the first order differential equations. But in chapter 4, we are going to mostly focus on doing almost the same thing, but this time using the higher order differential equations. So for the first part, we're going to focus on the initial value problem using the higher order differential equations. And in general, first to write down the title. Whoa, my hand, holy shit. Oh, this is the action mode. Yeah, this is the action mode. So understanding the initial value problem using the higher order differential equations. Right? So in general, the way we can, so there's a general equation actually for the initial value problem, which is an of x d to the power nx by dny dxn a n minus 1. So this is the n minus 1 differential equation, d to the power n minus 1 y dx to the power n minus 1 a of n minus 2 d of n minus 2 y by dx to the power n minus 2, so on, so on, so on, so on, so on, so on, plus a2 of x d square y by dx square plus a1 of x dy plus dx plus a0 of x y is equal to this entire thing is equal to g of x. Now I'm only using one hand, and you have your initial conditions. So you have y of x naught, it is y naught, y prime of x naught being y prime naught, not y prime naught, sorry, y1. I mean, it is y prime naught, but you call it y1, y prime prime of x naught being y2, and so on. Right? So what are we trying, what's going on? So we know that we're trying to define a problem. We want to find a function rather than going for one or first order differential equation. We're going to use nth order differential equation. We're given a problem. We want to find the function that satisfies the equation. We will do a few examples. So you can understand it fully. We will do a few examples. So do not worry about that. Now, the next one, which is the existence of unique solution, I would love to read using examples, but I'm not. I would love to explain it, but when I explain it, you may not be able to understand. So I'm going to use an example to explain it. All right. So let's do one example. So let's use the example that I'm going to use is from the exercise book. So you can check out the exercise questions from a book, and you can also see there are captions here. So I tried my best to edit the videos and stuff. So you should be able to not only hear, but also be able to know what is going on and stuff, right? So we can try one example. And this video could also be the first where I've, used the new, because I use CapCut. I just used CapCut, and from there was this option for captions, auto captions, and I just did that. This is also in the action form, so you're going to see it moves a lot. So I've kind of improved from the previous lecture because everyone wanted everything perfection, but nothing is going to be perfect when we begin. So we have one question. So let's try y prime prime plus y is equal to 0 with the initial conditions y of 0 is equal to 1 and y prime of 0 is equal to 1. Right? So one thing is that if we are given an equation, so let me explain a little bit. These are continuous equations. So you have a2 of x d square y by dx square plus a0 of x y. So you have a second order differential equation plus the 0th order differential equation. So which means my a2 of x is simply 1 here because it's 1 here. I don't have an a1 of x, so my a1 of x is simply 0 and my a0 of x would be 1. Main idea is that my a1 of x must not be, my a2 of x or an of x must not be 0. My an of x, which is the n being the highest order should not be 0. And in the case of here, my highest order, which is a2 of x, which is not 0, because my a2 of x is 1. Cool. Right? So because I have a1 of x as 0, a2 of x as 1, so I can say that they have a unique solution. So this is what you call an existence and a unique solution. So there is a unique solution. Main idea is that it is in this format or any differential equation, and your leading coefficient, which in this case is a second order differential equation, must not be 0. So if your a2 of x in this case was considered 0, obviously you would not have a2 of 0 if it was considered 0, but if it is not 0, then you can consider it as being a unique solution. And it doesn't have to be only for 2, it can be for 3, 4, 5, as long as that is the leading coefficient. Right? And so if we were to segregate it, so highest order is 2. Your is it linear, non-linear? It is linear, and it is homogeneous. Right? Let us try another example. Let's try problem 4, where y prime prime plus xy is equal to 0, where y of 0 is equal to 2, and y prime of 0 is minus 1. Once again, if we look at the equation here, first of all, this is a nonlinear. So I can immediately say this is a nonlinear. And my highest order is a second order, and my second order is not 0. y of 0 is 2, y prime of 0 is -1. However, my a2 of x is not 0, it is 1. a1 of x is 0, and a0 of x is 1. My g of x is 0. Forget about these two initial conditions, which we'll be focusing that later on. I'll divide this into a few more lectures because 4.1 is a little bit difficult. So I'm going to divide it so that everyone understands. But one thing is to configure that your highest order differential equation is not 0. It is 1. Right? It is 1. Here on we can say it is nonlinear, it is homogeneous, and it's a second order differential equation. So nonlinear, homogeneous, and it's a second order. Right? So there is a unique solution. Yes, I know it is nonlinear, but it is a unique solution because your highest order is not 0. You guys can try one. Now, this is a little tricky. So you have y prime prime plus 4y is equal to sine of x. Now it's not plus minus, just plus. And your y of 0 is equal to 0. And y prime of 0 is equal to 0. Now you can take your time. So I want you guys to observe what's the highest order derivative here. Is it linear, non-linear? Is it unique? So I'm going to give you 10 seconds. All right. First thing first, this is a linear. Reason being is because it's a 4y, so we're not changing anything to that. So it is linear. It is a second order. So it's a linear. It is a second order differential equation. And is it unique? So if I look at a2 of x, this is 1, a1 of x is 0, a0 of x is 4, and g of x is sine x. Now, as long as the highest order derivative is not 0, it is considered feasible. So it is a unique solution. Cool. We will continue a bit more in the next lecture. Like I said, chapter 4 is a little bit difficult, so I don't want to put everything in one video. I'm going to divide them into a few lectures, and this video is also a test as to how is the audio, how is the captions and stuff. All right, so I hope you guys understood, and I'll see you in the next lecture.